Welcome back to LocalM Tuts. I am Nilay Parikh. This is lesson 8 of 16, A2A with Microsoft Agent Framework. In last lesson, we built the client side, discovering agent, sending tasks, handling both blocking and streaming responses. If you're watching this as a standalone video, find the complete course playlist in link below description and follow along with a lesson. Here is what you'll find all the code for the lesson. The GitHub repository link is in description, as well as the interactive tutorial page link in description. Clone the repo, open the lesson folder and follow. 3 files: Orchestrator with the tool, decorated function, server that expose it over A2A, and client to test it. The orchestrator uses A2A agent proxy object to call the remote agent discovered via the agent cards. The A2A agent proxy is a key pattern. It wraps any remote A2A agent as a local callable. The orchestrator doesn't know what framework or model the remote agent uses. It just sees the agent card and sends the task. Let's see this in action. Install the dependencies, configure your Azure credentials, then start the server and client in separate terminals. Watch the orchestrator discover agent via their agent cards and route the task using LLM-based tool calling. Pause the video and try it yourself. Just one quick note. You don't need Azure credentials or Azure AI Foundry to run this example. Microsoft Agent Framework is agnostic. You can use with other open source OpenAI compatible URLs, as well as you can discover many different methods and many different compatibility with their documentation. So please follow if something different you would like to try with this example, but we will keep it simple with our Azure Foundry AI. Welcome to lesson 8. Practical example, A2A wrapping with the orchestrator agent. In this, we will validate the loan validation as we pass our various loan application and see what happens. The architecture is pretty simple. From lesson 8 to lesson 13, they all try to solve the same problem, but using different SDKs. And they all try to adhere the A2A protocol. So let's see the first Microsoft Agent Framework. We have 3 components: the client, which will connect, the orchestrator, which will orchestrate the agent, and the server, which will host the A2A connection. And then the 2 common files, which will across all the SDKs examples. The loan data, instead of creating a database, I just created a simple Python file with the loan. And the validation rules. So they have a common validation rule where they can accept or reject, just to make sure we have a result parity. Now, once this example is run, it can also log the complete auditability, what it did, what happened, what is the reasoning behind the rejection or acceptance, and what it did. And if I go in the loan data, then this is what we generally expect. We expect couple to review, couple to decline, and couple to approve. So now let's run very simply. To run it, you go on the Microsoft Agent Framework path, simply set up, I assume you have already set up your Python virtual environment or the environment that you're running, and then simply python server.py. So I think we are in the wrong folder. cd src Python server, and I'll go there in the client as well, src, and I'll just see if the server is up and running. Yep, server is up and running on 10,008, and I will just say client.py, which will try to process the data. So we can see here it is processing data, and actually it is going to Azure by now. So let me see if I can get also Azure. Okay, while it is running. Let's see. And if you don't have access to this particular Visual Studio Code or examples at the time you're watching this, you can actually use our interactive page where there is a lot of information to read, understand, and it explained in a very detail. And if you're especially preparing for like interviews and other, there are really interesting questions that you can go through and actually validate while running this thing. And also we have very detailed run steps, so hopefully it should not be difficult for anyone to make this example run. But let's see whether the monitor does work. And yes, we see this. We suddenly see after this is the time I'm running, and we now have certain tokens going through. So it is connecting into Kimi-K2-Thinking. Oh, there you go. We are done. So it did same, like it rejected bulk 1, yes, when declined. It given a very good reasoning as well why it has declined. And this is again, I'm trying to mention that agents are not supposed to be deterministically rejecting or accepting. Agent must do semantic and agentic analysis and provide a proper reasoning and flags. So these flags and risk flags reasoning is not generated by deterministic. It's generated by thinking model. And there is another conversation some other day we'll do why thinking model and why thinking model do better than non-thinking model. And for this particular application, the thinking model is very useful. And we'll walk in some other particular tutorial where we will discuss but specifically this point, that regular reasoning model versus reasoning thinking model and how to implement and benefit from thinking. So well, it did everything, and none of this comes via the deterministic coding. It all comes via the agent itself, and the detail verify log is here. As we can see, it just drop it here as well. So that's good. So very well, we actually did the Microsoft Agent Framework. It's a simple but really useful. We can see we are using Agent Framework here, and it's really interesting. Thanks for watching this lesson on LocalM Tuts. In the next lesson, Google ADK shows how simple A2A integration can be. Just one function call with A2A. You can find the next video in A2A protocol course playlist. Links in description. I see you there.